Welcome to our talk about challenges when operating 1,000 plus different AEM applications. I'm Pramod. I work for Adobe as a AEM cloud SME, and my main focus is to adopt or connect the rapidly evolving Adobe's AEM cloud services platform with the unique implementation needs of every organization. With me, I have Jörg, well known in the AEM community for his blogs and technical talks. Yeah.
Yeah, I'm Jörg. You probably know me. Well, a few. I'm working as a site reliability engineer for AEM as a cloud service. I spent about a decade before in consulting. So I'm probably, Roman, I'm as long as you in the AEM world. I started with Communique 3.53 as well.
So our mission here is Jörg and his team regularly analyze AEM operational issues, and there he noticed an interesting pattern and had an idea to take this topic for adaptTo. So our mission here is to empower developers and engineers to realize a full potential of AEM cloud services to help them develop scalable and feature-ready solutions targeted for their organization's specific goals. So cloud services represent a fundamental shift from on-premises deployments. Now, where the core of AEM remains familiar, as we know it, cloud services introduce few operational practices around it, which sometimes new and surprising to developers who are accustomed to traditional AEM deployment and development. Now, let's look at some of those practices. Immutable infrastructure. In the cloud on-premises deployments, a user can access a direct file system. There is SSH connection directly to the server. Cloud services removes this capability completely. There is no direct access to the servers. All the configuration changes must go through Cloud Manager deployment. Also, there is a limited access to OSGI configurations, and server scaling is handled automatically. The entire infrastructure is managed by Adobe. Now, while these practices may seem restrictive to the developers accustomed to traditional AEM development, they provide they provide a really a solid foundation for introducing other benefits such as reliability, where there's a little configuration drift between on the instances, or there is no configuration drift. There's security. There is a very little attack surface exposed because of the services which are in place around it, or the operational practice around it, and also scalability, compliance, and efficiency around it. Now, let's look at some of the numbers on the AEM cloud services. These 1,000 plus distinct customer applications represent a wide variety and diversity of the technical requirements, industries, and also the different technical requirements. 50K plus AEM instances shows the different how large requires a complex infrastructure, as well as a monitoring and operational practices to manage them. On top of it, there is also a new AEM release almost every other week. Each release goes through a detailed testing as well as a rigorous validation before being rolled out to the customer environment. And so all these applications needs quite a bit of surrounding frameworks around it. Now let's look at the usual assumptions what we have onto the AEM on-premises. Developers who are used to on-premise development, as we said, has a direct access to the servers. Each instance is accessible, and one can also tune the JVM parameters on it. And that gives rise to quite a bit of configuration flexibility, but it also gives a full weight of operational practices around it, right from environment management to security patching, and quite a bit of operations around backup, restore. And this flexibility also means that operation practices can be fine-tuned for the specific application needs. So there are pros and cons of both of these. Organizations need to then evaluate in detail which operational model is best fit for them. Now, for some, on-premises might work well because of the regulatory requirements, and the flexibility might be something what they want. But for many others, cloud services represent a compelling alternative where organizations then can focus on their business need rather than focusing on their technical infrastructure. So AEM Cloud Services, as it stands, introduces quite a bit of operational principles to make the service really work at such a large scale. Let's look at some of those service principles. The platform is service-centric, and what that means is there are different microservices which are taking care of certain aspects of AEM. There's an author service focused on content creation. There's a publish service focused on delivering that content to the end users, a replication service for moving the content from authoring to publish instances. There's also a monitoring service for observations and monitoring of the AEM stats. And in addition to that, there is also an auto-scaling service which takes care of AEM operations and operational loads and scaling the services as and when that's needed. Uniform operations. All the customers or organizations which are on the cloud services, the operations are similar. All the deployments go through a cloud manager. Automation and auto-scaling is handled in the same way for all. And one of the other practice, the customization in cloud services is not possible, and that is due to the fact that, and this represents quite a significant change from the on-premises AEM deployment. And having those customization options not available, then while feel restrictive, but enables cloud services to scale to the large extent. Yeah.
Okay, so how can we achieve this? Because you're coming from a totally different world. We have 1,000 applications plus, which used to run on probably 1,000 different styles, 1,000 different ways how deployments were done, how backups were done, how you troubleshooted, how you scaled, all these operations. And the thing is, we need to have a common ground for various patterns. We need to something where we agree on, where we say we are doing it this way or we are doing it that way. And the thing in cloud service is we need to encourage you to do that because there is no other way. You cannot customize operations. You cannot customize various things you were used to customize. That means we need to focus on these good practices, and we need to probably even start to enforcing them, because if any deviations happens, it normally ends up in problems. Now the big challenge is, what are these good practices? To be honest, AEM/Adobe in the past never really cared about a lot of that stuff. We throw you the quick start, you did whatever you'd done, you ran it, you troubleshooted it, you might have raised a daycare ticket, and then we asked you to reproduce it on the quick start and not on your custom applications. But in the end, we never really cared. What are the perfect JVM parameters? How do you monitor stuff? How do you do X and Y and Z? Well, figure it out. And this is causing us a bit of problems because you figured it out. You solved the problem in your way and potentially in a very unique way. And that means we need to develop these good practices, we need to document them properly, and we need to make them actionable in a way that you know, we ask you to do X, and then you know how to do X. And the big thing is, we have done it in a few places before, but we were never able to enforce it. That means we could tell you to do X. Did we know if you do it that way? No, we didn't. We couldn't find it out. We couldn't force you to do so. But in cloud service, well, we probably have to do. I mean, sometimes we end up in situations where a lift and shift migration into cloud service is causing a bit of problem. Luckily, not that frequently, but frequently enough that we need to talk about a few things which we now care a lot, and we care much more than in the past. So I want to go through a few examples where we care much more about. So the first thing we need to mention is that the AEM lifecycle is fully automated. That means we have automation who decides when to start an instance and when to stop an instance. And this happens very, very frequently. That means we are starting up an instance and might shut it down and throw it away 30 minutes later. What's the problem? No, there is no problem. It works. It does what it's supposed to do, but you never did it in the past. On-prem, on AMS, you never had that situation. On top of that, publishers don't have persistent storage. That means if you go in the past, you went to each publish and changed something, and then you restarted them, and this change was there, not going to work anymore. In the past, we didn't care about startup time at all. If it took 25 minutes on your environment, it took 25 minutes. It wasn't our problem. Now it is. So, and why is that even important? Because our automation really relies on reliable behavior, no flakiness. It needs to behave always the same. It means it's not acceptable if the startup today takes 6 minutes and tomorrow when you start it up, it takes 1 hour because you added some migration step into a service startup. That's not going to work. It's not good. And the focus on startup time is especially important because we need to focus on elasticity, saying when you have more traffic, our automation detects that, starts up, auto-scaling, you have 3 more new publishes or 10. but that doesn't work if the startup takes 25 minutes. Has also the impact that the frequent startups, that they need to work reliably with empty caches. We cannot really pre-fill caches when it takes 10 minutes. It doesn't work. Which leads to the question, when is an AEM instance ready? Typically, in the old schools, I did it myself. I had a tail running on the error log, and I know it was ready when it stopped logging like crazy. That's the easy way, but hard to automate. So in the best way, fully automated would be when all services are running. The question is, what does all mean? Because not all services are supposed to run on every instance. Not to talk about custom services. So we ended up with something when the services, the most important services with the most complex dependencies are running, then we consider the application ready. It works very, very well. But on the other hand side, it also means we need to have detection to when it fails. If a service is not starting up, what do? We have implemented timeout saying, okay, when the instance is not ready within 20 minutes, there's probably something wrong, which makes your migration during startup time, which takes 30 minutes, a little bit problematic. But still, this is one of the things where an initial really cool decision to support auto-scaling have consequences in the end. Consequences into custom applications. So when is an instance ready? Some rules of thumb. Well, small instances are faster than larger. Yeah, normally. Although we are trying to make large instances as fast as small instances. And we always have a little bit the trade-off between the stability of the startup service, startup process, saying needs to get up as fast as possible, but that means, can we do shortcuts? Yeah, we can do some, but it needs still to be reliable. That means some caches need to be populated. And if they don't, performance is really poor. And, well, yeah. Talking about when is an application ready versus when is an overload happening. In the past, overloads, I don't know how we handled overloads. Probably when someone calls and says, you're delivering 503s or it's really slow. We had to implement something else. We need to have implemented an implicit or explicit overload detection. And we got always asked, these 429s, why do you start to deliver 429s? My thing is, well, I can give you a fast 429 or I can give you a slow 503. What do you prefer? Normally in the 503 case, the instance would fall over, would restart, and then would probably fall over again. Is this situation any better? In the 429, the case we actually manage the situation, at least some requests might get through. And also, the recovery is much easier. Because from this 503 situation, will be very, very hard to recover from that. So, how are we solving that? First, fully automated lifecycle, health check, based probes. We have I invested quite a bit of time into improvements in the startup, async initializations, removing of bottlenecks. And then, of course, we have a big thing, moving tasks from runtime to build time. In AEM, historically, a lot of stuff was done during runtime, because that's the thing which Adobe controlled. Means you need to build client libs, of course, to write your JavaScript and then throw it into AEM, and AEM try to make the best out of it. Compile, minify, whatever. Is it good? Yeah, it still can work, but we are doing better now, right? We have front-end builds, etc. JSP, HDL compilation. We can move a lot of stuff into build time because we have a process it anyway. So why do we need to do it at runtime? Another thing, backend connections. AEM as an integration platform. Yeah, works sometimes, but it's hard work. Synchronous, asynchronous calls to backend systems, and in cloud service, it's everything running in the cloud in a very software-defined network. There are many hops to your backend system and latency. At every hop, you have a small chance of network issues, etc. What I often miss with these backend things is timeouts, I miss error handling, I miss retries, and again miss timeouts, and general resilience against slow requests. That means if the backend is slow, well, bad things happen, because then the problem of your backend turns into a problem of AEM. And AEM doesn't only do backend requests, right? That means if all your Jetty threads are consumed because they're all waiting for a slow backend, you cannot even deliver an asset anymore. Thread pool exhaustion triggering the rate limiter, and the problem is monitoring is impossible because we cannot monitor the way how you do backend connections. You might use one of these 15 HTTP clients around. You might use a library. We cannot monitor them all. We could make some guesses, but so backend connections ensure that your AEM application can handle backend problems without failing over, without manual intervention. We cannot intervene. You might have done when it was running on-prem. We cannot do. But there are other ways to solve it. First of all, we have the architectural choice. It means we can configure multiple origins in the Fastly. That means you don't have to route everything through AEM. We can do the same on dispatcher. You don't have to run every traffic through AEM. We can provide an agent, and we can reach out to you. But, well, the first one is probably the most scalable way. It gives the choice to you. Second one is already reactive, and the third one does not scale at all. And typically very, very late.
So an effective caching is very crucial for AEM cloud services to scale and to have a better performance. However, we do notice that quite a few implementations do rely on dispatcher cache implicitly, and that does cause sometimes a problem, especially during the cold restarts. And organizations sometimes have a misconceptions around a CDN, that CDN cache is incompatible with a content or dynamic content, or where the content refresh is needed frequently. There are multiple other ways to actually solve that problem. So what causes this insufficient caching? Insufficient caching causes performance issues and scalability issues on the cloud services. Insufficient caching can be caused by over-aggressive flushing of the cache, where a certain resource needs to be flushed or removed from the cache, but the aggressive caching removes a whole section and then has to be recached again. The other problem could be where the content caches or the purges are also caused by a large number of query parameters. And that incorrect configuration on the caching or inefficient caching can then lead to problems where then organizations are not able to adapt to a sudden load in the traffic. So one need to have. So let's look at what the proper caching is. The proper caching is the CDN first approach, and what the CDN first approach is where most of the content request we aim to serve from the CDN layer. Now you may notice that when the request is served from the CDN layer, many resources are served less than 50 milliseconds time it takes for them. If the resource then not found in CDN cache and has to be served from the dispatcher, still takes somewhere around 200 milliseconds-ish. But if the resource needs to be served from the origin, then you might notice that quite often it takes more than 500 plus milliseconds to compile and then get the resource back to the end users. So this CDN first thinking is absolutely important. There are many toolings available to analyze the CDN traffic. There are Splunk dashboards available internal to Adobe to support users for looking at your CDN cache traffic. And there are also a tooling available with the Elk stack where one can download the CDN log from the Cloud Manager and push it through to the Elk stack. And now there is also a Jupyter notebook available where one can get the CDN log and then run it through the tool. Adobe CDN has quite a few features, has evolved quite a lot to provide the enterprise-grade features which were previously not available. The features include now a request and response manipulation, the header manipulation, as well as a WAF layer for finding and taking care of the usual attack signatures. One can also have a bring your own CDN, but then all the aspects of content caching are managed by the organizations. In many cases, you will notice that Adobe CDN is good enough for most of the common cases, as well as some advanced cases now. And so BYO CDN may not really be required for the features which organizations were looking for to move to in the past areas.
So what are we doing? What is the cloud service team doing? We are constantly improving AEM to avoid and fix problems, and in the best way, normally we do it under the hood. It means we don't want to bother you with all that stuff. We try to fix stuff transparently, covering all this, let's say, trying to integrate these best practices and, in the best case, not require any change on your side. But this is not always possible. I briefly talked with Carsten before, and there will be changes in the future where we need you to actually test your application when we switch to the Jakarta API, which will happen sometime in the future, not so far ahead in the future. We try to avoid this as good as we can. Backwards compatibility is the holy cow. We still rely a lot of it, but it's not always possible. What we try is to keep our documentation and outreaches actionable. In the past, we had a lot of documentation which are very high level, not specific. We try to improve that. And of course, we will always reach out to you, but at that point, we will try to provide actionable insights, actionable requests for changes. That means, please do X. We try to do that, and if we don't try, and if we don't deliver actionable outreaches, please let us know. Because in the end, we are both of us together in that same boat. So we are much more opinionated than 10 years ago. As I said before, we didn't care a lot about best practices. We just we gave it to you and said, yeah, figure it out how to do it. We cannot afford to do that anymore. And it also means some things have changed. Some things everyone did 2014 are probably not, or might not be applicable anymore on cloud service. That means when you migrate to cloud service, or if you have migrated to cloud service, you might need a few things. You might need to change a few things. For most likely, many of these implicit assumptions, which we try to outline here. Thank you.
Thank you, Jörg and Pramod, for the wonderful conversation. You already have quite a few questions in the pipeline. The first one is, could you elaborate on how leader selection works when AEM authors are recycling or restarting? I have seen the is leader to be unreliable and wonder what is the proper way to find out which instance, for example, is responsible for running workflows or any other actions. It's a big one.
That's a big one. We could talk about it for half an hour. If you don't mind, we would, whoever raised that question, please approach me either today or maybe tomorrow. We can work on that. Basically, leader election is currently, I would like to have it replaced as soon as possible in the current way to have something more reliable, but it is what it is right now. But I can give you all the details afterwards. It's probably just these Q&A sessions, probably not the right format for it.
Yeah, maybe you can approach during the Meet the Expert session to get into it. We have another one which also has quite a few votes. How do you synchronize the content on newly created publishers after startup?
Synchronize the content after startup. Normal replication, right? That means, well, depends on how deep you want to go.
They do have a follow-up, to be honest. So how do you decide when all the states on all publishers are the same, especially when there are ongoing publications?
We don't know. It's called eventual consistency. Think about CDN and all that stuff. There is no guarantee what Sanya say, now this changes life everywhere in this world. We can probably say, well, maybe after 12 hours, all the cache is timed out. But honestly, it's very, very hard to say, yes, now we are delivering everywhere. We can probably make good assumptions, but it's not that easy to make. And honestly, even on-prem, this was very, very hard.
I think we can get into one last question before wrapping up. Any numbers about how much startup time was reduced across years and how long it takes on average to have a new instance ready?
I think the AEM startup, in a normal case, it's about, let's say, from the provisioning of the hardware, let's say the allocation, till publish is live, it's about 4 minutes, 4 to 5 minutes, and in the slow cases, maybe 7. But I think this is quite good.
Great.
That means,
Oh, sorry. Yeah. Please go ahead.
Thank you.
Yeah, so thank you, and that's it for the first talk. Again, a huge round of applause, please, for Jörg and Pramod.